Welcome to another episode of Thinking Critically. Today I am joined by the trio from Scopes and Scrubs. I have Marisol, Juliana, as well as Lindsey. They are three students that are in what is known as an MD PhD program. So they are medical scientists in training. Currently third year, is that right? Third year, fourth year? Third year. Just
Time flies.
All right, wonderful.
Yeah.
But anyway, thank you so much for joining. It's really great to have you.
Thank you.
Thanks so much.
Happy to be here.
Yeah, wonderful, wonderful. So, we'll go ahead and start with you, Marisol. How exactly did you find yourself to be in an MD PhD program? Let's hear your science journey.
Of course. Yeah. Excited to share this one. So full disclosure, I did not know an MD PhD program existed until I started college, but I can definitely pinpoint a couple things in my life that kind of got me interested in science in the first place and kind of opened me up to those sorts of programs and ultimately put me here where I am right now. So my parents own a preschool, and growing up, I was always surrounded by teaching, education. I loved working with kids, and I actually always imagined myself being a teacher. It really wasn't until high school where I started taking these science and math courses, and I would say biology specifically, that got me extremely excited about human physiology and everything like related to the body. And then at that point, I think I realized that as a doctor, you are basically a teacher, but like at a different level. And so I think it was in high school where I made the switch from being teacher to being doctor. And so I did start college. I went to Florida International University in Miami, where I'm originally from. And that's where I started doing a pre-med track. I actually got into a research program while it was like part of my pre-med track, but it had a focus on research. And so starting freshman year, I did get asked, or like the program requires you to kind of join a lab. And at that point, I started thinking about what in science I was interested in. My grandma had Alzheimer's disease. And I think always as a child, I always questioned why her brain was different. And I kind of saw the whole transition. So I saw her from when she could perfectly recognize me and talk to me and have a conversation with me and eat by herself and all those things that we kind of take advantage of now. But she transitioned. I saw that transition from her being a normal functioning human being to someone who was suffering from Alzheimer's disease, and she couldn't recognize me. She couldn't hold conversation, and she couldn't even take care of herself. And so I think growing up, seeing that transition always got me interested in the brain and why brains differ from person to person. And so I did join a neuroscience lab my freshman year of undergrad, kind of asking psychological questions. And I kind of wanted to get deeper and deeper into understanding the brain. So I moved to like a neuroengineering lab, just trying to parse out what the brain is. And so for a long time, I think since college, I was really fascinated by the brain. Now I am currently, as you mentioned, in an MD PhD program where I do study the brain. I'm getting a PhD in neuroscience, and ultimately I do want to be a neurosurgeon who also does neuroscience research. But that was kind of my track, and I think little random things that kind of all together culminated to what are my passions and interests now.
Yeah, that's super interesting. And do you think it really was seeing what your grandmother went through that led you more towards neuroscience, or were there other things?
I think there's several things. I want to highlight that one, but I am also left-handed, and I mean, I like read a lot about like what it means to be left-handed, like growing up, just like out of pure interest. And I stumbled upon psychiatric research that pointed at a lot of like schizophrenic being left-handed, like a majority of the population. I was like, oh, that's so interesting how something so simple that we don't even think about, like your hand preference, can lead to or could be correlated to psychiatric disorders. And schizophrenia, among a lot of psychiatric disorders, are very fascinating, and the fact that like we know nothing about them is quite interesting. And so I think little things like that just kind of pointed me towards the neuroscience specifically. The brain is just so fascinating, and now that I'm actually taking neuroscience courses, little things that we like take for granted. So for example, when you're running, your vision focuses on your surrounding, so that when you're running and you're bouncing up and down when you're running, the image in front of you isn't bouncing as well, right? Otherwise you would you'd be nauseous trying to walk, like even from walking or being in a car that's like bumpy. Your eyes are capable of just fixing the environment in place so that you don't have to deal with that. And there's people that like have disorders that this nerve that connects to the rest of the brain and kind of pieces all these things together is not functioning. And as a result, like just by them walking, their vision is just bouncing up and down. And that's something so simple and stupid that we don't think about, like what we're looking at right now. And I think it's very fascinating that the brain, which is so small and maybe like very small part of our body, can be doing such computational things that are very interesting.
Yeah, it's truly fascinating. And what you were saying about, taking for granted the little things, and so I'm assuming that the brain is what fixes the environment around you. It's not actually something that's done on a eye level, like from like a fine muscle tuning, but it's actually something that the brain fixes, or is it maybe both? I don't know.
So it's a combination. So it's actually called like the vestibulo-ocular I forget exactly, reflex, vestibulo-ocular reflex.
Okay.
And so it takes in input from your ears, which has the vestibular system. For those that don't know, you have 3 rings in your ear, all fixing different orientations, X, Y, Z. And when you tilt your head, there's actually fluid in there that moves. And when it moves, it triggers these hair cells that are in that fluid to send electricity into your brain. And it tells you, okay, your head's oriented in this direction, your head's oriented in this direction. So a combination of your head orientation, which comes from your ear, is being sent and combined with the eye information that you're getting, and that is all being translated and sent to your brain to let you know and fix the image.
That's super interesting.
It's just like a lot of little things, and it happens so fast. That's phenomenal as well. So you can think of neuroscience like both mathematically, like computationally. You can think about it behaviorally. You can think it in systems, like how the whole thing comes together and makes you, your personality, and whatever that could be called. So there's a lot of like neuroengineering as well. If you're doing prosthetic devices, that takes in like an engineering side. So I think there's a lot you can do with neuroscience, and it's very fascinating.
Yeah, I'm an amateur neuroscientist, I like to say.
Join the dark side.
I've done it. What'd you say?
I said join the dark side.
Join the dark side.
We need more physics people.
What's interesting is that at one point in my career, because I'm fascinated by biology and I have a number of family members who work in the medical field. Growing up, my mother was an oral surgeon, and I considered actually doing an MD PhD at one point in my life because I really like medicine a lot. But I also love physics. So I was thinking about doing biophysics and then combining an MD with a PhD, particularly because I didn't want to pay for the MD either, because medical school is very difficult to get covered or to get scholarships for. But if you combine it with the PhD track, PhDs in science are so easy to get funding for, so you could get the whole thing paid for, just, spend an extra 2 years or whatever.
Yeah,
so
that's
but anyway,
but now there's a lot of free med schools, or that's emerging concept.
Is it? Okay, well, I'm a proponent of that. Yeah. Okay, so Juliana and Lindsey, so let's hear, who wants to go first? Let's hear your story. I'm very interested.
Our stories kind of will intertwine, so I guess you can start off.
I'll start, and then you can jump in.
So we're identical twins.
Yeah, so we're identical twins.
I didn't notice.
It's hard to tell.
So we grew up around medicine. So my dad's a physician, so I was always exposed to medicine. So went into undergraduate on the pre-med track. Knew I wanted to be a doctor. And then during my freshman year, I was at Columbia for undergrad, and my mentor in lab, I saw a talk that he presented, and I just thought it was like incredibly fascinating. It was about how the brain processes smell. And I never really thought about research before that, but I sent him an email and I was like, I would really be interested in hearing more and working in the lab if you'd be willing to take on an undergrad. So I went in and I interviewed, and I was able to work in the lab during that summer. And then I ended up staying in that same lab all throughout undergraduate, and went and researched during the summers and was there during the year. I was there all the time. I fell in love with research, and I knew that it needed to be a part of my career. And like Marisol, didn't know about the MD PhD program until later, until I realized that I wanted to incorporate research. And they make it easy for you if you have an interest in both, because there's the MSCP programs, medical scientist training program. So that's how I got involved in that. And I
guess it's a similar story. So I also grew up exposed to medicine, and I guess it shows you kind of a nature versus nurture thing. We've always had kind of similar but different interests. Because I feel like I guess it's just our genetic wiring. We're exposed in nature. We're exposed to the same things, and we both can talk about what we're interested in. So growing up, we had a lot of similar interests, and I was also interested in medicine because of seeing my dad, and as well as like in high school taking science classes, that always just clicked for me and came like more naturally. So then in college, I knew I wanted to do medicine, and then I joined a lab. I actually joined a stem cell biology lab. I was a neuroscience major, but was kind of like fascinated, and it seemed so elusive to me, the world of like stem cells. I didn't really know what they were, but it sounded really like people always talked about it. There was like some controversy. I was like, what are they? So then I got in a stem cell biology lab, studying intestinal stem cells in flies, and I really liked it. My mentor was an MD PhD. So that was kind of my first exposure to like, I didn't know you could do this. I didn't know it was like a set program. So having that mentor was very important to me. And then I realized I really liked research. And yeah, I wanted it to be incorporated. And now I still study stem cells biology, but in bone. So I kind of kept along that track. But I still find neuroscience very interesting, but kind of went a different way.
The stem cells are fascinating though. I mean, would you say that stem cells will like dominate, like regenerative medicine is going to kind of like dominate this decade? Because it seems like it's becoming more and more popular, and that the potential of stem cell therapy across all swaths of anything healthcare related, it just seems incredible to me.
Yeah, so we're both do. Yeah, so now
you're both doing stem cells.
Yeah,
okay.
So so we both do stem cells,
but the neuro aspect.
I keep the neuro aspect. So I study how nerves impact stem cells, specifically in the skin. But we're both in the regenerative medicine department, and so I study skin stem cells. She studies bone stem cells, but it's nice because we all join together as like a collective unit to kind of think about regenerative medicine and have these sessions.
And a lot of stem cells have similar properties, and a huge problem is your stem cells' capacity to function declines as you age. So that's why we see a lot of age-related degeneration of things. So understanding how they function in a normal, young, healthy state and how we can manipulate them to be kind of like superpowered cells in aging, or use young cells in aging, is kind of a really interesting area that I'm excited about, and I think still has a long way to go, but could be a really good area of improving medicine, especially in orthopedics.
Super, super interesting. Okay, so in your research, because I'm fascinated by stem cells as well. So what type of stem cells do you work with? Like, I know that there's like various stages. Do you take like adult cells and then you convert them back to, I don't know, like totipotent, pluripotent? I'm not sure about these terminologies. Maybe you can help me with this, but there are stem cells like placental stem cells, which can essentially turn into anything, right? Like any aspect of the body. Okay. Now, is that pluripotent or totipotent? I can't remember. Or is it something else?
I think totipotent is like everything that's in the embryo. That's like the
everything.
Very beginning. Yeah. But then it becomes when most people study embryonic stem cells.
Okay.
But those are pluripotent because they lose the ability to become the trophoblast, which is like one little part of the embryo. So then they call those pluripotent. But they can pretty much become like any layer of the body. Like you have 3 different layers, and those cells can become any one of those. So that's typically pluripotent is typically like encompasses everything except for that.
Okay.
What about the omnipotent ones? These are all triggering words for like undergrad.
Oh yeah, you're
omnipotent.
Is that not a one?
I'm sure it's a type of stem cell, but we both actually study.
No, it's not.
We both move a little further along the line, and we're in like adult stem cell. So like
multipotent cells that only have a few fates.
Yeah.
So I do bone stem cells.
I do skin, but not studying it as early as like ES stem cells and culture work. A little bit of that, but using the mouse as a model, and then looking at how these cells kind of progress throughout development. But
I did go to a New York stem cell conference, and Yamanaka, who discovered the Yamanaka factors, was there, and I was like, that was one of the moments I was super starstruck.
You were starstruck?
I was so starstruck because he's the person who took the skin cell and then using a few transcription factors was able to like revert it back to like an embryonic stem cell like state. So
he was the guy. He was the individual that did that, because that's like that was a huge step in stem cell therapies. I know, particularly moving away from actually using like the embryonic stem cells, because that's contentious and historically, and they were able to move away from using those because of that process developed.
Yeah, so now you could take skin cells and then just revert those or anything really, and just using like a handful of transcription factors, reprogram them, which is like a huge development. And I think it's actually being used a lot in neuroscience now to create models of neurons and things like that. So it all connects, right?
Yep.
That's super
we need you
interesting.
guys.
Okay, so all right, so you just finished your third year of school. Are you done with med school and now it's research, or how exactly does the MD PhD process work?
Yeah, so usually, go ahead, Julie.
Go ahead.
It's hard to figure out. Okay.
Go.
So usually the way MD PhD programs work is that you do your first 2 years of medical school, and then you go and you do your 4 years plus or minus years, depending on how well or what your project is. And then you wrap up and you do your last 2 years of med school. So the first 2 years of med school are mostly preclinical stuff is what they call it. And it's all mostly textbook and lectures and learning about the different systems in your body and learning how to talk to patients and, that sort of thing. And then the last 2 years of medical school is actually when you're in the hospital with different teams and rotating throughout different specialties. So currently right now we are wrapping up, or I guess finished our first year of graduate school, which is mostly course heavy. And then that kind of tapers out as you go through the grad years. You take less classes and you're more time in lab so you can work on your thesis project.
Very cool. So how did you meet? I'm assuming you met at school?
Yeah.
Yeah? Okay. So are you I'm assuming you're in the same class then?
Yeah, we're the same year in the same class. I actually had done a research program with Marisol's sister as an undergraduate at Rockefeller University. And so our class is 14 people. So it's a pretty, like the MD PhD class itself, our med school class is bigger, but so it's just a small group of us, and we were talking and we followed each other on Instagram, and I realized that I already had known her sister. So it's a really small world, but then, we met through being in the same MD PhD class, and we've been really close friends ever since.
Do you know there's only 14 of you? And is that typical for one class? Well, I know that MD PhDs, I mean, it's a fairly daunting degree program because what is it, 8 years on average?
Yeah.
So 8 years after undergraduate.
Yeah.
So, okay.
And
then do you have to go into like a residency afterwards as well?
Yeah.
Okay. So you like school.
Yeah. You commit. You like school. Yeah, but usually 14 is pretty big. That's a little bit above average for most programs. Most programs go from range from 7 to 10. And there's maybe some programs that do take 20 students. That's probably one school that I can think of off the top of my head. But this is we're kind of a bigger class. Everyone else is a little smaller.
That's per one, the entering year though. I think in the program total, there's probably
Yeah.
Okay.
But there's 1,000 MSTP students in the United States right now currently, with all the years included.
1,000 MD PhD students in the United States, you said?
Yeah, it's MSTP specifically, which is what Julie was pointing, which is the medical science training program. It just means the funding actually comes from the NIH versus private money. But within the MSTP program, there's currently 1,000 students in throughout all the years. So it's a relatively small program.
I see. So, just for clarity. So there are MD PhD programs, correct? But the MSTP, so that is an acronym for Medical Sciences Training Program? Okay.
It's an MD PhD program, but it's just it's different.
But it's funded, right? But it's funded. It's funded. Okay. So with an MD PhD, there's no guarantee of funding.
Right.
But if you get the MSTP. What's that?
Fund it through different mechanisms sometimes. Maybe you'll have private funding or the university solely will fund it. Whereas with MSTP, it's a established NIH supported program. So it's
okay,
like
I see.
little subtleties, but
it's still the same format and they do the same thing.
Format. They just
Yeah, but you don't have to pay for it, so it's even better.
Yeah.
Yeah, exactly. And you get a stipend too, which is something that a lot of people don't know. It pays for your medical school and you get a stipend all throughout your 8 years.
So you get a little bonus.
A little bonus, you can survive and live in New York City.
Be in school for 8 years.
Yeah, well,
Exactly.
I mean, there are worse places you could be.
That's
well,
true.
Yeah. I know with PhDs, and my experience going through my graduate school is that it's the same thing. That you can get funding, you usually get it from the university, but you have to do like a TA, a teaching assistantship. So that's where you teach labs, or you proctor classes, things of that nature. And then you have all your other responsibilities in addition to it, and you get a tuition waiver and then some funding or a stipend on top of it. It's not glamorous, but at least you don't have to pay for your school. Yeah. And I think that what most people don't realize is that the tuition waiver is actually not a full tuition waiver. Like mine's like 80% reduction. Like I still have to pay to go to school, but it's only like 20% of the original value. So I don't know if that's the same thing with MSTP programs, but I know with at least my science, like a PhD program, and I think with talking to other graduate students, other PhDs, like when you get funding, like they don't have a full tuition waiver, which would be nice.
Yeah, that's interesting.
So, but anyway, okay, so, all right, so you all met together in the MST program at NYU. Now, when did you decide to do Scopes and Scrubs? How did that all come about? I'd like to hear the origin stories of the
we
brand.
Can each say it. See, it's like when you ask a couple, like how did you guys meet?
Yeah.
We each have different stories. I'm kidding.
Okay, so let's see. How about Juliana or Lindsey? One of you. You can take the reins on this.
Take the reins.
So I think one thing that we realized was that we all didn't really know about the MD PhD program until college. So we're like, wow, there's really needs to be a better way to get the word out to people about this program, because being a physician scientist is such a cool career and more people need to know about it. And also just like showing people what we do with our daily lives. I think that, as I'm sure you know, like the career of a scientist is very elusive to the general public too. Like people don't know what a scientist does, generally.
Completely underappreciated.
Right. So we were like, it'd be cool to in Instagram. This was, I guess, 2 years ago when we started, right, guys?
Yeah, it was like our first year of med school.
Yeah. So Instagram was getting really big. And there are a lot of like the idea of the influencer was kind of popping up, and there was like all these different accounts highlighting different things. And we were like, what if we did it for medicine and science? And we all liked Instagram, independently, like being creative. So we just kind of sat down one day and had the idea and talked about it, and then threw up some pictures, and it kind of evolved as we went along. But
yeah, we always wanted it to be more of like just like both showing what our daily lives looked at like as MD PhD students, as well as we wanted to provide the mentorship that we received in college to other people. We answer questions in our DMs about what an MD PhD program is. We release YouTube videos. We read personal statements. So just kind of creating another resource in the social media realm, which is something that's pretty dominant within both our generation and younger generations. So we wanted to have a seat at the table there.
Yeah. And I think as it evolved, we started thinking more like broader of like how we can create a space like on social media that is like relevant for science and medicine, maybe also like women in science, like that might not have, like I never met a female MD PhD until I was like in an MD PhD program. And I feel like it's nice to have that kind of connection like with someone early on. And so we kind of create a space there where people can talk about what they're doing in science, what they're doing in medicine, and form collaboration with other doctors, other scientists, and kind of, I don't know, have a space in social media that is like relevant to what we do.
Yeah, that's awesome. I think your platform is fantastic. The website's great, and I think your Instagram account, there's a bunch of great information on there. And it seems as though you're doing pretty well. Like people have caught on to it, and I mean, have you gotten good positive feedback from society, I guess, you know, from your audience, you know, people like sending you DMs about, particularly like you said, you want to, connect with women, but all people who want to partake in MD, PhD programs. Have you gotten, a good amount of responses, DMs, asking for help, things of that nature?
Yeah, all the time. We always have to post like, we're sorry we can't get to your DMs. Like, we're just, we're really busy, and it helps that it's 3 of us, so we can sort of manage responsibilities and get to everyone's questions quickly. But I think we all 3 agree that one of the most fulfilling things is when people actually DM us saying like, oh, you read my personal statement last year. I just applied and I got accepted to my favorite school. Like, thank you so much. And it's like those little things like that that actually make Scopes and Scrubs like live and, keep going.
Yeah. Or the
awesome.
Like, oh,
or like, I got a bad grade. Do you think I should keep going, or should I just give up completely? So it's nice to be there and be like, keep going. If this is what you want to do,
you can do it. If I can do it, you can do it.
Even to provide that the bit of motivation from someone who's, in the MD PhD program.
Who's done it.
Yeah, who's done it.
I'm not so different.
Yeah. I've gotten bad grades on tests before. Like, keep going,
Yeah, I don't think anyone's gotten 100% on every single homework and test assignment.
Yeah. What? Yeah. That's not true.
Oh, yeah, I guess you're the only one there, so.
Yeah, I don't know what you guys talking about.
Yeah. I think our message overall is like pretty positive on our account. We're not like very controversial. We're just there for like to help out people, support people, and show kind of what we do on our day-to-day lives. So far it's only been a great experience.
Yeah, and we try to highlight the positive aspects because it is 90% of the time positive. I'm like every experience anyone has in any field, there's always those bad days, and everyone has those. But generally, we're just so happy with what we do, and we love it. So people always, sometimes that's a criticism. People say it's like, you guys only post the positive, but I think it's just because we want it. That's what we want to showcase. And like everything, you can be negative, but why be negative when you can showcase the positive things and why you like it, and not deter people away from our field. So.
Yeah, there's nothing wrong with that. I mean, it's your account. You can kind of, and at the end of the day, do whatever you want with it. And I know that, as far as highlighting only the positives, I'm assuming that when people actually, talk to you, DM you, and ask you for advice, saying I'm having a hard time, like, you're going to tell them, hey, it's fine.
Oh, of course.
These things happen. Yeah. It's not like you're actively trying to hide it. No, that's fantastic. I think overall that like I said before, I think the brand is really cool. I have been on Instagram for, I don't know, like a year, maybe a year and a half. And I followed a bunch of different science communicators, but I don't really see a whole lot of MD, like medical scientists, like MD PhDs going out there and doing that. I see a lot of PhDs, but not so much and MDs, but not so much the combination of the medical scientists. Although there is one other account that is really interesting by the name of immunofluorescence. It's this MD PhD student somewhere on the East Coast. I don't know if you've ever heard of this individual, and he does nothing but post his research. It's just gorgeous. They're just like basically slides.
Histology is amazing.
What'd you say?
That histology is like one of the prettiest things you can post about. I always think that
that's exactly precisely histology. That's it. Yeah, his account is nothing but histology, and with all these gorgeous filters, and they look like portraits.
Yeah, that's beautiful.
And it's like, this was built for Instagram.
Oh,
yeah.
This is my phone background. I have cells. I just
yeah, exactly. The entire account is nothing but that. And he gets like thousands of likes and whatnot. And I was like, I can understand. This was built for Instagram.
I always think DJs should use those images like in their DJ sets, when they project like lasers in the background. It should just be histology images. Like, they're so beautiful.
They're so pretty.
And you could be learning too. Maybe you could put out, or she could put out some sort of tidbits of medical advice here and there within the music, and then put up.
Should we all be DJs then?
I'll leave that to you. I'll just follow you on social media. So. That's funny. Okay, so you have approximately how long until, so you're halfway through the program roughly, or you said it's going to be about 8 years until, or was it 6 years until you graduate? So you're 3 years in, graduate.
Like 5 years?
5 years?
Approximately.
Roughly?
Roughly okay. 5 years.
Approximately, okay. So what then? So Marisol, I know that you said you wanted to go into neurosurgery. So why that particular area? So have you done anything surgery-wise, or do you only do surgery when it comes to like the residency afterwards, or is that something that you do as a actual student? Do you get to be?
You can really participate as a student, which is extremely nice. And if you find good neurosurgeons that are willing to work with you, they would let you be in the OR, which is the operating room. Some people might not know that. Let you be in the operating room and help out. And I was lucky that I was able to get involved with a neurosurgery project that works with Parkinson patients. And I was able to go in, set up. So in these surgeries, these patients are awake. They're just anesthetized, so they can't feel that someone's poking their brain or like opening their skull. But these patients are awake, and we were doing actually some experiments on them. And I was one of the lead students. Lindsey actually was involved with this early on. Yeah. And I also am involved with other neurosurgery clinical papers that I've been writing. So it's really easy as a med student to get involved with neurosurgery. I mean, obviously, they're not going to give you a scalpel and be like, here, take over this patient.
As soon as you walk in the door?
Yeah, I mean, I wish. But you basically can be there, and being there is already like step one, right? And then you do residency where you actually get trained in all of this. But for me, it was a process of elimination. I started when I knew I wanted to do neuroscience. I basically limited myself to 3 clinical areas, I believe so, which was neurology, psychiatry, and neurosurgery. And I kind of just shifted through all 3 until I really realized that neurosurgery was what I particularly was very interested in. And I always kind of say the story, and like in the lab, there's a lot of like delayed gratification. It might take a month, 2 months, a year for you to discover something that's actually meaningful for you, or the experiments finally run the way you want them to. With neurosurgery, a patient comes in, specifically if it's like functional neurosurgery, where it's a Parkinson's patient, they come in with a tremor, you stick a device in them, 2 hours later, they walk out, their tremor is gone, and there's no delayed gratification there. And I kind of really like the balance of having delayed gratification in the lab, but then also going in, seeing a patient, and being able to help them restore function in literally 3 hours or so. So I think I found that balance doing a combination of neuroscience and neurosurgery. I think I didn't find that anywhere else, especially in psychiatry, where I feel like it's just, we don't know anything. It's kind of sad and scary. I feel like that would have been too much uncertainty in both sides, in the lab and in the clinics. I don't think I would have been able to handle that.
Are you talking about the very soft science nature of psychiatry when you say we don't know anything? That's
a rough term, but I want to say, like, you know, someone has someone has a cardiovascular problem, you kind of know exactly what you're going to give them, and you're going to know how long it's going to take before they feel better. With psychiatry, there's so much overlap with all these psychiatric disorders. It's really hard to diagnose someone. I mean, there's a manual that people follow, and that's what's used clinically. But it's very hard to be 100% exact that that's what that patient has. And in addition to that, you might have one psychiatric disorder, but you might also have a couple others that are kind of like comorbidities that come with one psychiatric disorder. So it's very hard to just assume that with one drug, you can fix that. And then in another sense, we also don't know anything about the brain. And so it's very hard to, you know, see some sort of behavioral change and try to, you know, with a drug or with some sort of therapy, try to fix that to what we consider normal when we basically don't even know what's normal. But that's just a problem with neuroscience in general. That makes it also fascinating.
Yeah, exactly. There's a lot to learn, right?
Yeah.
And I should clarify, I don't mean to bash psychiatry. My stepmother is actually a psychologist, and my mom, before she went on to dental school, got a bachelor's degree in psychology. I'm fascinated by psychology, but as a physicist, I do know that there are certain limitations, particularly within psychiatry. So that is the medical treatment of psychological disorders, things of that nature, that it has a very rough history. And it is getting better, and that more diagnostic techniques are being infused into it. But that was all. That's all that I meant by soft science. I didn't mean to offend.
No, you did not offend. I just didn't want to like repeat it.
Yeah.
But
so neurosurgery, and then Juliana and Lindsey, what would be the next steps for you guys, for you two?
I think both of us are still kind of exploring and deciding. That's the kind of cool thing about MD PhD programs or medical school. You can go in. Some people like Marisol know what they want to do from the beginning, and you can explore that and just build on it. But it's also exciting because there's so many different things you can do, and if you don't know, you can explore and kind of use this time to explore different areas and see what you're interested in. I study bone stem cells. I'm definitely interested in the field of orthopedics, but we'll see what that means for my specialty when I get there.
Yeah, exactly.
We don't have to decide till we're in our and when we go back to medical school.
Right.
So in a few years.
But not even then. I feel like a lot of students, so if you're doing like the traditional 4-year med school path, most students don't decide until like their end of 3rd year, once they've rotated through all the specialties and they have a better idea. It's not till then, until like you have to actually apply to residency, that people don't decide. So like you technically have like 4 or 5 years.
Got time.
So residency is kind of really where you specialize then, right? So you kind of just get a generic education, or generic medical education, I should say, over the first 4 years or so. And then you specialize into residency, kind of pick what area of medicine it is that you want to work in.
Exactly. Yeah.
It's like similar to a postdoc. Where you like kind of decide like what you might piggyback your potential research on when you open your own lab, if that's what you want to do.
I see.
At this point, it's like what you're more narrowing down your interests to one area of medicine.
Okay, that makes sense. What would you say, like, what excites you most, I guess, moving forward, like in medicine, within medical science? What are you most excited about? Obviously, the things that you're researching, I guess. I mean, maybe that would be it, but. I mean, I guess out of everything in the medical sphere that's being done these days, what do you think are some of the more exciting advancements, things of that nature that people should be excited about?
I think single cell RNA sequencing.
You can't read a paper now without doing single cell RNA sequencing. So now they can sequence cells on like an individual level.
We should talk this morning about it.
Yeah,
it's really good.
And literally every paper.
Yeah, and you can diagnose diseases now based off of knowing how different cells, the genome of single cells, and that's really interesting and fascinating to think about in terms of the future of like precision medicine and tailoring treatments to individuals.
Maybe actually say with single sequencing.
Yes, like. Before you would do this thing called bulk RNA-seq, where you would sequence, you'd get a tissue, either human or mouse or whatever organism you're working with, and you would just sequence all the cells together and gather information about them, like on a collective level about their like total RNA content, and just kind of infer things about that. So now they have this technology. They have a few different ways you can go about it. Mostly it's droplet based, where like there's like lipid droplets that like attract the cell, and so you can do it like on a cell by cell basis and sequence the cells. And so then when you put the cells together, you can use computational methods to cluster cells with similar expression identities together. Say, oh, these cells all express similar things, so they must be like one group of cells like osteoblasts, which are bone cells, and these group of cells express things that make them look like fibroblasts. And you can like say, oh, but within the fibroblasts, there's like even more categorizations. So it gives you just like a more detailed look, where before we're getting a really broad picture. Now you can get more nuanced. And so that's opened a lot of doors. And I think seeing technologies like this and how that you can even just go further than this and think about how they'll improve even more on this, doing things at a protein level, because right now it's on an RNA level, which you're starting to do, but still working on. So I think that's really exciting to see technologies like this. And I think we're going to get more and more detailed understanding of the human body through this.
That's super interesting. I have never heard of that before. I mean, I've heard of like genomic sequencing and things like that, but I haven't heard about this cutting edge stuff, which is surprising because I do a lot of reading, and I'm like subscribed to a bunch of different science magazines and things like that, and I'm just surprised I never heard of this.
You've definitely seen it. It just they just like now that you know, you'll know, and you'll see a paper and you'll be like, exactly. And now I know.
Yeah. Well, I'm sorry, what's the name again?
single cell RNA sequencing.
Single cell RNA sequencing. Okay.
It's a mouthful.
I think I'm gonna have to Google that later.
Yeah, and it all goes back to computation, like computational biology as well. So I think I tell people when they DM us on Scopes and Scrubs, like, what should I learn? I'm like, learn how to code, have the proficiency in like any type of coding language, like preferably maybe like R or MATLAB. I think a lot of science is being pushed in that direction towards like big data. So I think that that technology, like what underlies it is like having a proficiency in these different coding languages, so you can manipulate large data sets, which provides a whole new set of opportunities and discoveries.
Yeah, I think that these days it's almost impossible to be a scientist and not know how to program because of the large volumes of data that you're dealing with these days. It's just impossible to do it, obviously, by hand. You need to use computers in order to use the computers, and these various programs you need to understand, you need to know how to code. I think like all of society is kind of pushing that way, big data. I mean, they're saying like data is more valuable than oil now. It's the most valuable resource on the planet. And science is definitely going that direction, along with a bunch of other fields as well, or areas of society. So coding. Okay, so you said R, MATLAB. What are some other languages that you work with? I'm assuming you all are programmers, or you have done some coding.
I think Marisol's probably the most.
Yeah, probably the most. Yeah, R and MATLAB, basic level.
She's got the most proficiency in coding.
I look at brain activity in animals that's probably recorded over long periods of time, and you have to be able to detect certain signals specifically that's encoded in this big electrical activity that you're collecting. So I do use like MATLAB and Python a lot in the lab. But what's really nice since in a lot of neuroscience labs, since you're using a lot of code and most people are looking at similar features in the brain activity, all of this is kind of like mainstream now. So you can go into GitHub, which is a very like popular website where you can kind of download all these scripts that people use to find particular pieces of information like within their data sets. So I think it's getting nicer now to like kind of do computational work, because there's a lot of scripts written out there and you don't have to spend like days or weeks or months like troubleshooting something that someone already has made. And so it's kind of really nice that the science community is out there willing to like share data, willing to share scripts and stuff like that, which I think is going to move science even faster nowadays. But going back to like technology things, I think the hospitals are going to be functioning very different. Maybe even by the time we start residency, I think there's a lot of interest in like using robotics and like diagnostic algorithms. So right now at like one of our hospitals, we have like a robot that cleans the floor, and it just knows like how to avoid people, how to clean the floor, how to get in the elevator, how to click the elevator button or how to get to the second floor or the third floor. It knows not to take the stairs and like fall. And this same robot also delivers food to patients, which is kind of incredible. So I can see more of medicine kind of moving into more like technology, which will be really fascinating for us to see once we're actually practicing in the hospital.
So I've seen robotic surgeons. I've seen remarkable videos of, and what in particular, I don't know if it's called Da Vinci or it's got some really cool name. The Da Vinci? Yeah. Okay, so the one where they peel the skin off of a grape and then sew it back on?
Yep.
Have you seen that video?
Yes,
I'm assuming you've seen that video. I've seen that video. That's incredible. So was that done? I can't remember if that was done by remote operation or was an actual surgeon in the room operating that. Like, the reason I ask is I was saying, like, you know, are you worried about not having a job in surgery because you have all of these robots?
Yeah.
Now? I don't think that obviously surgeons would go. You think they're going to go completely away?
One of those robots costs so much money. It costs more money to do that than to pay a surgeon.
Maybe way down the line.
I think Julie saw one of these.
I've seen it. Yeah, I've seen the Da Vinci robot. But when I was in there, it was really funny because I couldn't tell who was like operating it. But then I looked and I saw the surgeon was sitting like in the corner of the room, like it looked like he was playing a video game. It was really cool.
They actually say now that one of the best surgical skills you can have is video games.
It was crazy to watch.
I just couldn't believe the level of precision. It was remarkable. It was absolutely remarkable.
Yeah,
and that's exactly what you would need for a robotic surgeon though, because that's the type of precision that the actual surgeon needs to have in the operating room, because one, you know, you're talking about if you're off by millimeters, you could end up killing someone, particularly in neurosurgery. Obviously, Marisol, you would know more about this than I would, but it's very, very sensitive structures. And I mean, I would think, I mean, I guess I'm just
surprisingly, you have a lot of space in the brain, but one of the biggest problems is like bleeding. And actually to solve this, Elon Musk just created this like robot that can go into the brain and actually it scans for blood vessels so that it can, let's say it's implanting a device, it can kind of, if it sees a blood vessel, it moves around it, which is quite fascinating.
Oh,
I'm assuming he created that for Neuralink.
Yeah, so he's using it to like implant electrodes into the human brain. And so it's a robot that comes in and like implants these flexible electrodes, but it sees the blood vessel, it moves, and then keeps moving down. So we do this in animals, and we implant these electrodes so we can record their activity. And this takes me like 8-hour surgery, maybe 6 to 8 hours. This robot does it in 20 minutes, and like it also avoids bleeding. And I'm just like, what am I doing? But it's really fascinating, like the fact that like technology in the future might be able to do that and cut down on a lot of time that we spend in lab doing kind of like the silly side of science, which is just prepping experiments, right?
How would you even prep yourself for a 6 to 8 hour surgery where you have to be on your feet and like in somebody's head, or in your case, you're dealing with an animal? But I don't even know, because I've heard of people like surgeons doing surgeries for like a day, like they were there for 20 to 24 hours. It's like, is it a tag team, or like, I just don't even know. Because something that's always baffled my mind is just how long as a medical doctor, like when you're actually in the, like doing your rounds, maybe in like the ER, or maybe you're on a shift or whatever, how long they are. And to be, you know, you have to be at your best, I guess, like during that entire shift, and maybe not the entire time, but you're going to have people's lives in your hands potentially. So I'm just curious as to what the atmosphere is, because I'm not a part of that. How would you even prep yourself for something like that?
The kind of surgeries
like
I
toughness?
do,
yeah,
I listen to podcasts and queue up playlists. And so, and I think you just really have to like it. There's a lot of things that we do in the lab. One of them is surgeries, and I can say like probably 10% of the lab actually enjoys doing the surgery. I am part of that 10%. Like I absolutely love surgery days. And so I have a blast doing it, and I always queue up just something to entertain myself, like in my head. But otherwise, like, I think it's like, if you like playing video games and you can sit and play video games for 8 hours, or you like watching movies and you can sit and do that, or like reading for 8 hours, I think if you like it, you'll be entertained the whole entire way. I'm not sure. Yeah, I think so.
For you, it's a flow state. Okay.
Yeah, I don't know what 24 hours would feel like, and going past that and standing. I'm like actually sitting and comfortable. But yeah,
adrenaline that pushes you through on those.
I think so too.
Hour surgeries, just the excitement.
Well, the same person does it for an entire day. Like there's no like multiple surgeons operating.
Those are rare. They're probably doing something pretty like monumental.
Yeah, usually those surgeries are like, I don't know,
like a Ben Carson separating twins or something like that.
Yeah,
like something crazy.
Or like a trauma case, but I feel like in trauma you still have like different teams coming in.
Yeah, there's like more than one person in the room too, so it's not like you're like sitting there alone like for 20 hours. I feel like there's like people like checking what you're doing, and there's lots of people involved, so kind of a sense of like teamwork. That can kind of get you through too. Yeah.
Super interesting. Yeah, I was always really impressed by the longevity of people that work in the healthcare industry, because I just don't know if I could do that, you know, stay up for whatever, a full day or 36 hours or whatever on rotations. And
I don't think anyone's ever prepared for that.
Yeah, no, that's just something that it's kind of like going to boot camp.
You have to do to get there. Yeah, exactly.
Yeah. Okay.
They're building your stamina.
All right. So something that I was perusing your website, and I know that you have this on your Instagram too. What exactly does it mean to be a STEMinist? I obviously know that that is a compound word between STEM and feminist, but I was just curious as to what it means to you three.
I mean, I think we're trying to, it's the whole combining of like science and feminism into one shirt. I think it really just represents.
Quite catchy.
Yes, right? It has a little ring to it. I think it just represents like female in science. I mean, science, as you know, has always been majority male dominated.
Yeah.
And for us, I think it's more just like we are female and we are scientists, and it's not a weird thing. Like this is normal, and like we enjoy this, and these are like the benefits of doing looking into science or being a female in sciences. I think like that's like the bigger picture. Like what's kind of amazing now is that the incoming MD PhD class is 10 students, and all 10 of them are female, which is like the first time probably in history that this ever has happened. And I think that's what that shirt means.
Okay. Yeah, well, no one usually would, if the whole class was male, whole MD PhD class was male, usually people wouldn't think much of it, you know, but when it's 10 females, people are like, oh my gosh, this is so unusual, this is crazy. So it's kind of the paradigm switch where, you know, females are entering the scientific field, establishing a place, it's becoming the new norm. And so I think it's wonderful. And I'm so happy that our program is promoting that, and it's happening, and we're embracing it. And that's what it means to be a STEMinist.
That's pretty awesome. I am a huge fan of that, and I wish that physics would follow the same suit, because unfortunately physics is still very heavily male dominated.
Yeah, I was in a neuroengineering lab in college, and I was the only female in like 20 people lab, and they were all boys.
Engineering too, I think.
Engineering,
very male dominated. Medicine, I've noticed though, there is more women in that go into like biology and medicine, and I don't know why, but it just seems as though they're more attracted to those fields. But it would be wonderful if there were more women in physics. I can tell you that much.
Yeah, we hope. Anyone listening?
Yeah, someday, right? It's definitely, there's been a shift, because as you had mentioned, historically, women in general have been in low numbers in science, but you are seeing more and more of that as the years go on. So that's pretty awesome.
Yeah. Next up, physics.
And next up, physics, right? So as scientists in training, I am curious to your thoughts of the kind of atmosphere, the anti-science atmosphere, like the fake news stuff, particularly like all the conspiracy theories that have been propagated since the pandemic started. People, as you had mentioned earlier, don't seem to understand or appreciate what it is that scientists do, and really, really don't want to listen to them. They think that going on to YouTube and watching a bunch of videos, and I'm not saying that YouTube isn't a good source, because it is. I mean, I'm pretty sure I watched YouTube earlier today for some videos, and I will later tonight. But to think that because you've watched a bunch of videos on YouTube, or maybe you've read some articles on Google, that your training is somehow equivalent to what a scientist does, a decade post baccalaureate degree. I was just curious as to your thoughts on that. I mean, I have opinions, but but as scientists in training, I mean, do you think it's alarming? I mean, how do you feel about all that?
Yeah, I think there's definitely, and I think it's harder too with the media. I think that what happens is someone publishes an article on something that can be twisted and be very catchy, and create like a flashy headline. I can't think of a good example of one in my head right now.
They always use the M&M example for statistics, how people don't understand statistics, or the jelly bean.
They don't. I don't understand statistics.
They'll be try to correlate like green jelly beans to acne.
That's the example.
People can look this up. Green jelly beans to acne, and they find like one instance it becomes statistically significant.
Green jelly beans cause acne.
So then there's like a headline like green jelly beans cause acne. So
no one goes in and like reads the paper to see like,
that's super trendy.
Look at the science behind it. So I feel like a lot of the media will grab onto like a really cool like article that's in Cell or Nature or Science or something, and not really
infer maybe too much.
Yeah. Categorically agree. The media does that a lot, and it doesn't matter the media outlet. They're all engaging in this type of activity. And I'm not going to sit here and say that you shouldn't, like, all media is bad, but but the sensationalism, I mean, this desire to grab your attention has led certain outlets, I mean, and it's not just in the media, but people in general, to make more and more crazier headlines and kind of distort the truth a little bit in order to grab your attention and generate revenue. With statistics, though, in particular, statistics are so easily manipulated. And I almost feel slightly embarrassed because I don't really understand statistics that well. know, I have a degree in math. One of my degrees is in math, but I only took one stats class. So I have a very poor background in statistics. And I was actually just having a conversation not too long ago with a neuroscientist out of Mount Sinai. And we were talking about the stats thing and how in science, because big data is becoming so dominant, and it looks like it will in the immediate future, that every peer review board should actually have a PhD in statistics just to ensure the quality, the fidelity of the statistics that are presented in the paper. Because not every scientist is going to be a PhD level statistician. And because it's so open to interpretation and things of that nature, that it's almost an imperative at this point.
Yeah.
But yes, stats are definitely in the media misrepresenting scientific findings. I agree.
I also want to play devil's advocate here and say that, I mean, so before I was ever in science, I would succumb to these like what we call like fake news articles. And I want to say that as scientists, we have a responsibility to interpret these results and kind of, I mean, like the whole science communication thing, like the reason why we want Scopes and Scrubs to kind of talk about science, talk about how to interpret data, talk about, you know, what's real, what's not real. And I think scientists have a huge role in this. And for the past like decades, we have been ignoring this responsibility that we've had as scientists. And so I want to say that, yes, it is a combination of media trying to make things mainstream, but also scientists not defending their research and not explaining the research to the general public. That, I mean, some science is really hard to read. And if you don't have the time or the interest in it, you're just going to read the article that's up and easy to read. And so I think as scientists, we have a responsibility to help in that interpretation, and we have to kind of step up our game.
That's a great point. Well said.
No, yeah, absolutely. Science communication is needed more than ever, in my opinion, these days, just because, you know, people have access to the wealth of human knowledge at their fingertips. You walk around with your smart devices, everything's so interconnected these days. But unfortunately, with access to all of this information, people get confused. They don't know who to listen to. They don't know what's true, what's wrong. And particularly when it comes to science, I mean, there were traditional channels that people went to in order to hear about it, and they never really questioned it. But then people get access to all of this information. They see YouTube videos questioning the science. They're like, oh, there must be something wrong. Maybe there's some sort of grand conspiracy between the world's governments, scientists, and Bill Gates to put microchips in us via vaccines. And so maybe I'll listen to this person on YouTube. And again, it's kind of like a breakdown of scientists stepping out into the community and communicating their research or just general science to the public. And I'm super excited to see all the various science communicators out there, such as yourselves, making an attempt to do that and to get people excited about science. So
yeah, and what you're doing. Yeah,
thumbs up. So that's awesome. But anyway, I think this was probably a good time to stop. But like, as far as where people can find you, like, where are you? So you have a website, you're on Instagram, where else? Where are you? Where's Scopes and Scrubs?
So we have our Instagram at Scopes and Scrubs. We have our website, scopesandscrubs.org. And we have another exciting avenue coming up soon. Our YouTube. Oh yeah, our YouTube, which is just YouTube, Scopes and Scrubs. And yeah, we're going to be doing another social media platform too.
Wink, wink.
Wink, wink. Okay.
That one will be more science communication, which is going to be really fun.
Yeah, we're going to try to do more
of the science communication stuff.
Yeah.
Will it be like generalized or particular to medicine? Generalized. Okay.
Yeah,
generalized, but a little bit of our unique projects and stuff.
Yeah. Okay.
But like, so everyone can understand, even if you don't have science.
So you don't want to drop the line right now?
We have to break the news like on our Instagram first.
Okay, that would make sense.
Go follow us on Scopes and Scrubs.
Okay, well, yeah, you heard it. Go follow them and you'll find out. Okay, well, I'm super excited to see what that's all about. Anyway, yeah, thank you so much for joining.
Thanks so much for having us.
Yeah, absolutely. Yeah, my pleasure.
Great conversation.
And for those of you tuning in at home, thank you so much for tuning in, and until next time.
Yeah,
bye, everyone.
Bye.
Bye.